All right. I'm gonna turn off my webcam. Well, first I'll let Travis introduce himself.
Good morning or afternoon, depending on where you're at. My name is Travis Kinney. I work for David Evans and Associates, and I have the honor of co-chairing this working group, the Bridge Preservation Local Agency Outreach Working Group. And I'll kick it back to Jason, who's my co-chair.
Thanks, Travis. So my name's Jason DeRuyver. I work for HDR. I'm the co-chair of the Local Agency Outreach Working Group. I spent 18 years at the Michigan DOT before going to HDR. So as their bridge maintenance engineer. Got a good presentation here today on bridge drift removal and scour maintenance, hopefully, that you find of value. With that, I'm going to get started. Stuart, do you want to introduce yourself real quick? Since you're on
Yes,
camera.
good morning. My name is Stuart Lenz. I am the Bridge Preservation Engineer for the Bridge Preservation Partnerships and National Center for Pavement Preservation. Like I say, I kind of am the liaison between the regional partnerships, the working groups, and the masses.
All right, thanks, Stuart. So we'll get started today. Before we get started, a little bit of housekeeping I wanted to go over. Feel free to type questions. There should be a drop-down button that says questions. You can type questions there. So at any time during the presentation, both Stuart and Travis will be tracking those and either answering them in the question box, or if they think it's a good discussion item, they'll break into the presentation and we'll start discussing it there. Let's see. You can also put in the question box or the chat what you want to see in upcoming trainings. We do this every other month throughout the year. If there's a topic that you'd like to see us discuss, feel free to drop that in the questions. Also, Stuart's going to talk about here in a second the continuing education certificates. If you didn't register or just got this link somehow, or weren't forwarded, or if you were forwarded the email invite and we don't have your contact information, please drop that in the chat so we can get your future invites out to you. And then go with Stuart and talk about continuing education.
All right. Is that the certificates are automatically generated by the software here, and to get a certificate and to have validation that you are actually in attendance, you will have to be registered and logged into the meeting as attending the meeting. If you are watching as a group and not logged in, I have no way of validating and verifying and that people are in attendance. My recommendation is that your supervisor would take a certificate that's generated for someone that is logged into the meeting in attendance and modify that to meet your needs. Sorry for that inconvenience, but there's not a way that we can verify that you're in attendance if you're not logged into the meeting. Thank you.
And just a note that this presentation is being recorded and will be made available at some point after the meeting on our Bridge Preservation Partnership website. Like I said, this is the Bridge Preservation Partnership. It's split into 4 regions of the country, and it's kind of a collaboration and cooperation between all these agencies listed on the left. We have university professors, industry consultants, federal highway, and local agencies. So I wanted to let you know about our in-person meetings coming up. We decided to go with joint partnership meetings this year. So the Southeast and the Western Bridge Preservation Partnership will be meeting in Denver, Colorado, March 10th through the 12th. And this fall, we don't have anything announced yet. In Chicago, Illinois, we'll have the Northeast Bridge Preservation Partnership and the Midwest Bridge Preservation Partnership. Local agencies are encouraged and welcome to attend these in-person meetings. I also wanted to bring up another piece of reference that's out there for free, is the Bridge Maintenance Reference Manual. And there's also an FHWA NHI course that goes with it, but it's currently online and available for anyone to download. I was able to find it, actually a PDF version of it online at the Florida DOT's website, just by Google searching FHWA Bridge Maintenance Reference Manual. So today we're talking about drift removal, and we're going to start off with what's the big deal with drift? How do I spot issues that are potential issues? We're going to talk about environmental and safety issues. We're going to talk about how to prioritize your drift removal, and then we're going to go into some best practices as well as proactive practices for removing your drift and sediment. So debris against a bridge can do several things to the stream and the bridge. Not only does it decreases the hydraulic capacity underneath the bridge, but it also increases velocity. That increased velocity of the stream increases the sediment transport, which increases the scour potential. As well as in some cases, extreme cases like in this view here, could increase lateral pressure on the bridge that may or may not have been even designed for. Drift and sediment is not just a bridge problem. You can see here that as sediment blocks one of the culverts, it continues to build up and starts to get vegetated and can completely close off part of the channel, causing stream migration. And you can see here that this hydraulic opening is supposed to be 2 of these culverts and is currently only 1, so it's greatly reduced. So in a flood event, this culvert is going to be way undersized that is accessible. Isn't it? There we go. So once you have a culvert that is undersized, or because of the adjacent culvert being blocked or the existing culvert is blocked, water's still going to find a way. It's going to start piping around the culvert, washing more sediment down the stream. It can start overtopping the roadway, start washing away the road, and eventually possibly cause a roadway failure like we see here in the bottom right corner. So these increased velocities in your streams can also cause perched ends to your stream. It can have a perched inlet to your culvert. It can have a perched outlet to your culvert with these increased velocities. You can see here at the outlet in the bottom right corner here that the stream degradation that this high velocity has caused, exiting the culvert, has degraded the stream several feet. And has actually started to undermine the head wall and the culvert apron at the outlet, and has actually broken the head wall. The head wall is starting to tip over. This can lead to slope failure as well behind the culvert. So you're going to want to make sure what we're doing is to reduce velocities, reducing turbulence, reducing sediment transport. Some problems are not so obvious. Sometimes if you're walking down a slope to look at the end of a culvert, you might see some holes in the slope. This isn't necessarily an animal hole. This is if it's directly over the culvert, stick a probe in there, see how deep it is. It's probably caused from some kind of ingress of soil from above in your culvert, where there might have been some settlement in your culvert due to some scouring issues that opened up seams in your culvert and joints that the dirt can get through now, and you're starting to see that problem up on the slope. In the bottom right, you can see that there's some patching in the shoulder where the roadway was depressed and failing, and it's directly above a culvert. Is there ingress of sediment into that culvert that you'll need to investigate. Like I said, not all problems are obvious. You can see in the bottom right corner of this, where this debris is stacked up against the column, that you can see the scour hole, how it's magnified because of the debris at the column. But then on the left side, sometimes these scour holes, they'll scour out during a flood event. And then as the stream settles out and settles down, those scour holes will fill back in. I was inspecting this bridge and walking along on this stream bed and noticed this soil right here is very soft on the left picture, and was easily able to push this 4-foot hole into the ground for about 3 feet. So that was a sign of an old scour hole that just kind of filled back in. So you can see the influence of there as well. But like I said, it's not necessarily easy to spot. Here's some other problems. It looks like you got a little pothole in the bottom right corner, but you stick a range pole in there, and it's actually a 3-foot deep undermining of the roadway directly above a culvert. On the left picture, we have a real sneaky, it's probably a concrete shoulder, so it's bridging over a 4-foot void under the shoulder. So these can cause problems when if traffic drives over them, and they can collapse. So when you're out and looking at your culverts, make sure you're also looking along the way and directly over them. Some environmental considerations. Primarily, you're going to want to make sure you schedule any drift removal outside of any fishing restrictions. If you have a lot of, like, Michigan has a lot of trout streams, and we have a lot of restrictions on when debris can be removed as long as it's outside of spawning. I'm sure Oregon has the same issue where Travis is at with the salmon. If it's a navigable waterway you need to remove drift from, you're going to have to check with the Army Corps if they're going to require a permit to remove that drift. The language in the CFR is kind of it's kind of very loose and ambiguous. They define a structure. The definition of structure includes any obstacle or obstruction which drift qualifies for, and they define working in the water. That definition includes the removal of, and it just says any material. So obviously, Army Corps will need to be consulted on navigable waterways, but the biggest recommendation is always going to be to check your local state agency for other requirements. So I looked into Michigan DEQ. We're very sensitive to fishing and fish habitats. So, and anything that could possibly disturb the river bottom. So if your drift is wedged into the river bottom, that's going to disturb the river bottom. And also drift makes great fish habitat. So you're going to need a permit for any removals in Michigan. Oregon, I guess, has a removal fill law that says that more than 50 cubic yards of debris that's removed requires a permit, or if you're working in a salmon habitat. Looked at Kentucky. Kentucky has no permit needed to remove drift if you're following their best practice document, which has things like not accessing too much of the disturbing too much of the banks, accessing responsibly, not driving equipment into the river, and so on and so forth.
Yeah, Jason, I'll just add on to that in Oregon, it's highly encouraged from the environmental perspective to turn and float the drift down to your neighbor's bridge. Yeah. I say that facetiously, but that really is what the desire is to send it downstream and hope it doesn't get hung up on your next one.
Yeah. Yeah, I think one of the Kentucky best practices I looked at included to cut and turn, which we'll have a slide on later. Okay. Side note, this webinar is only focused on debris and drift that poses an immediate threat to public safety and infrastructure. We recommend not touching debris or drift that does not pose that threat. So if it's outside the influence of your bridge, you know, if this log across the stream is downstream of your bridge, just let it lie. Accessibility considerations, you're going to want to look at what your traffic control requirements are for the bridge or the culvert where you're doing this work at. You're going to look at, is the traffic control going to have to be day or night, and let those things kind of inform your decisions on what kind of safety requirements and safety equipment you need out there. You'll also want to, if you need to go down the slope to access the drift, you're going to want to look at the condition of the slope, see if it actually is accessible, if there's an accessible point that you can get into the stream to the drift. You're also going to want to maintain safe distances from utilities while removing drift. And if you cannot maintain those safe distances, you're going to have to work with the utility department or the utility owner to have the power lines de-energized. That's important to do. You'll probably even want a spotter out there, because you're not going to be able to, person operating the equipment, or it's probably not going to have a good sense of how far away from the utility they are. Went to the OSHA requirements, and these are the clearance requirements that OSHA recommends for clear distances based on voltage of the overhead power lines you're working near. Like I said, you'll probably have to, if it's close to the bridge, you'll probably have to find out from the utility what the voltage is and if they have any other special requirements for clearance. And if you can't meet that, like I said, they'll need to de-energize the line for you to do the work. Also take a look at your structure condition. Does your structure have the capacity to have equipment on it? If you decide to do your debris removal with equipment parked on the bridge, you're going to want to make sure that the condition of the bridge is such that it can handle the load of the equipment on the bridge. Not only that, if you're doing like a paving project here on the upper right, they discovered that there was a huge void above a culvert with this compaction roller for this paving project, unfortunately. So it's just things to think about why, when you're looking at culverts, why I stress soil ingress into the culvert as being problematic. So how do you decide which bridges you should look at first for drift removal? First, we're going to talk about, is your bridge scour critical or not? If it's not scour critical, you're going to want to, it's not as high a priority. If it is scour critical, you should consider the removal of drift a high priority for yourself. Everyone should have the scour criticality of their bridge flagged in the bridge file. It's metric number 18. It's required by the Federal Highway Administration to have your bridge evaluated for scour vulnerability. And if it is listed as scour critical, or if it's determined to be scour critical, you need to have a plan of action. Going to show some samples of what some of the plans of action look like from Michigan DOT and the information that we provide. So it'd be helpful, and some of the information is helpful to also help with determining whether or not you should prioritize your drift removal. So you can see here, this bridge here, they have a scour analysis done for the 100-year and the 500-year flood, showing between 1.5 to 4 feet of freeboard, depending on the flood event that they had. There's also in the scour action plan, items to consider for bridge closure. So if you have high debris accumulation during and a flood event, this bridge should be closed until the event is over. So if your bridge is flagged as having to be closed if there's high debris during a flood event, then you might want to make sure the debris piles are out of there before the high flood event. This bridge is this is probably the highest priority in the inventory to make sure you get to for debris. Is this bridge also experiences pressure flow, so it already has a hydraulic capacity issue. flagged in the scour action plan. So it's very susceptible to scour under pressure flow, and high debris accumulation reduces that hydraulic opening, further worsening the scour issue. You can see here, even at the 50-year flood, this is flagged as having 0 freeboard. So that's not a very big flood recurrence. Another highest priority, I would say, is if you have a scour critical bridge that has an existing foundation issue. Up here in the upper right, this is one of those sneaky scour holes that filled back in, but it projects well underneath the footing. In fact, some of the footing is even undermined. You can see the footing exposed here, and you can easily stick that rain pole underneath the footing. Over here, this is an issue on the bottom left here. I see a pile there, but guess what? A pile doesn't mean that it's scour stable. Some of these old timber piles were purely there for construction purposes without scour in mind. Additionally, in this situation, you can already see that there's soil coming out from underneath the abutment, and that can start to lose your approach. So if there's debris that starts piling up here, that's going to be a high concern. So other considerations, you know, a lot of these, there's actually, the USGS has a lot of stream gauge monitors, and you can actually go in and look at your individual bridge location and see what projected flows are and historical flows and when the high flows are throughout the year, without having to do a lot of legwork going out in the field to monitor yourself. So you can actually go to that USGS site for your stream, try to figure out the best time of year to remove debris for the lowest water depth and lowest velocity of the water at the time, because that's desirable when you're out doing debris work. So equipment. This is pulled from some of the best practices from that Kentucky document I was talking about. It says, do not drive heavy machinery into the stream. The goal for every state on every debris removal project would be to minimize your stream bottom disruption. You're also going to want to minimize the number of access points to the stream bank. This Kentucky document recommends rubber tires to reduce disturbance of soil on your equipment over track-driven equipment, because the track-driven equipment obviously tears up more of the soil, and tearing up more of the soil on the adjacent stream banks will increase your future erosion. Additionally, don't do anything that disturbs the stream banks, or try not to disturb the existing stream banks. Those are what holds the water in, and reduces destabilizing them will cause future problems. Some more drift removal best practices here. In low flow streams with small pieces, you can wade in there, maybe take a chainsaw in there or some kind of hook where you just kind of grab it and turn it and let it float down. Hopefully it doesn't float down to the next bridge. Hopefully it floats off to the side and gets hung up on the bank and sets in there and makes some more fish habitat for you. So you can see on the right here, these guys are using what looks like some kind of grappling hook to lasso down below the bridge to try and break loose some of the debris. Really large debris like this, you're probably going to want to haul away. At a minimum, if you're just going to leave it, you're going to want to place that drift above the ordinary high water mark, or in this case here in this picture, remove it completely from the job site for something that big. I mean, you could try and set it free and do a cut, turn, and float like Travis indicated. Just got to kind of figure that out, how well that'd float in a low stream event here. You can also, Michigan DOT, I pulled this from their spec book. You can run it through a wood chipper before hauling it away and then dispose of it, just to kind of make it more reasonable and not need a giant flatbed truck to get it out of there. You know, cut it up into smaller pieces, manageable on site. You can also just burn it, build a big bonfire. But there's a warning against using hazardous material as a kindling. I'm sure they don't have the warning in there because no one ever did it. They have the warning there because people used to try and do that. So, so don't use plastics, tires, fuel oils to set your wood on fire.
And this goes without saying, but I'll say it anyways, and get it clear from the bridge before you light it up.
Yeah, don't start the fire under the bridge.
Unless you're really trying to get rid of that bridge.
Yeah. Here's another example of this one. They kind of use this clamshell bucket to grab it from one side of the bridge and then put it down on the other side of the bridge. However, I didn't like this picture that I found because it looks like he's just dropping it from a height 10, 15 feet above the river. That's going to plunge down into the river, disturb the stream bottom. It would have been better if you would have just kind of, you know, emptied it out a little bit closer to the water or even a lot closer to the water. So it minimizes that stream bottom disruption when before it starts to float away. Equipment, if you're using a chainsaw in the water or under the water, make sure you're using environmentally friendly lubricants. And, you know, this is the time to innovate with your equipment too. I talked to my Indiana DOT counterpart when I was at Michigan DOT, and he was hiring these large vehicle wreckers to come out with the bridge crews and help them crane out some of the bigger log jams. So we're going to cover some other practices, kind of focused on culverts here because everyone has lots of culverts compared to their bridge inventory. And they're just as important because culvert failures also cause road failures. So we've got flushing here. If you're going to use a fire hose or a fire hydrant nearby that you're lucky enough to have for your water source, make sure you reach out to your fire department and see what they have for requirements. Our flushing crew that I managed, you know, as a practice, we had these backflow preventers we put on the fire hydrant before connecting our water lines to them. Here's just a little video showing this culvert being jetted out. So it's going to pan to the right and you're going to see they've got some kind of protection there so the sediment doesn't necessarily go downstream. As they're jetting it out, they can remove it properly. Here's an example of a culvert on the left that was completely sedimented in. Can't see barely any of the return walls or the side walls. If it was panned out a little bit, you can kind of see up here that the slope was starting to fail as it's getting undermined by the water not being able to access the culvert. The water's going to find a way no matter what. So what they did is they came in, cleaned it all out. You can see all the return walls again. They kind of rip-wrapped where the bank used to be before it got sedimented in and jammed with debris. They've got their silt fence out to make sure that they don't spread anything. So this is all nice and cleaned out now. There's other things. There's bucket lines you can get drug through culverts to clean them out. Found this handy tool. It's like almost looks like a arrowhead as it pushes into the culvert, and then these fins right here open up and grab all the debris on the way out, kind of like that. Looks like they're using it for even small culverts and large box culverts. Excavators come in mini size. So don't be afraid to go use a miniature excavator. Here's an example of a operated mini excavator. Next, I'm going to show a video of this triple box culvert being cleaned out with an actual excavator that's so small it's remote control. Here comes the remote control. I love this video. I mean, I would have loved to have been the operator of this. It reminds me of my childhood sandbox. Been so fun. So,
As the video's playing, Jason, do you have any suggestions on how to prevent it from silting in again in the future?
I mean, I think it's just a natural thing that happens. I mean, but at the same time, I'm guessing it's never had the silt removed. I mean, this culvert could be 50 years old and never had anyone think about removing the silt. So if it just gets on like some kind of I mean, this is big enough to be considered a bridge. So
yeah,
so you should have maintenance recommendations for something like this.
Yeah, the only thing I've seen folks try with some situations is improve the hydraulic velocity by kind of channelizing a meandering stream a little bit to increase the flow to try and keep it from.
That definitely takes a permit because you're not allowed to necessarily straighten out meandering streams all the time.
Right.
As much as we'd like to. So, yeah, this is probably just some kind of drainage ditch between two farm fields is my guess. And, the water probably doesn't have a lot of flow. So it's just going to naturally silt in over time. So here it is, all cleaned out and nice now. Here's a bridge on the shore of Lake Superior. This is kind of a little different, but we did fix it with a vacuum. If you've ever been to Lake Superior in the Upper Peninsula of Michigan, there is a constant frigid breeze coming off of that lake that on this sandy beach has blown into the bridge. You can see here, you can't see the beam ends. You can't see the abutment. The sand is actually packed in. If the lighting was a little better, the sand is actually packed in all the way to the deck bottom. So it was really packed in there, and you can't inspect the beam ends or the abutment in its current condition. So we went in there with a vac truck, and we actually vacuum excavated out like it was like 4 truckloads of dirt. Gravel haulers. So this picture was taken about 8 years after we removed the sand up there. You can see it's starting to sand in again a little bit. There's nothing really to stop it. You just kind of make sure it doesn't get to that point again. You can see we got the abutment and the beam ends again can be inspected. So here's a video. This is a vacuum excavation where they're loosening up the dirt with water jets, uncovering the end of this culvert that had been lost.
Yeah, it's impressive that they still knew there was a culvert there.
It is impressive. So this culvert, this corrugated metal pipe culvert was being inspected, and you can see here at the ground level the rust forming. The inspector was like, well, that rust looks suspiciously thin, or the culvert remaining section looks suspiciously thin. I'm gonna pound on it with a hammer and see if my eyes are playing tricks on me or if it is really thin. and he kind of lightly struck it with a hammer. The hammer went all the way through, and little did he know that there was a river of liquid sand behind. So that hole that all that dirt's coming out of is only the size of a hammerhead. So the bridge crew that was trying to fix this named it the Wendy's Frosty machine for the culvert. So because that's kind of what it looked like coming out. Here's another here's a way to mitigate some infiltration. You can do grout injections. You can see here the grout ports are installed, and they're not installed on top of the crack. What you do is you actually drill into the concrete at an angle and angle your port through the crack from away from it. So you'll drill in, and if anyone's done concrete drilling before through a crack like this, you know you've gone deep enough and you've hit the crack because you can actually feel your concrete drill going through the crack when you're drilling it. Once you've got your ports installed, then you want to come back with a hydraulic cement, and you're going to want to hydraulic cement that crack so none of your grout that you're going to inject leaks out into your stream below. Then once you get the hydraulic cement's all cured and set, you can come back. You're going to first flush everything with water. That's going to start pouring out of your ports, and then you're going to inject your grout. If you suspect there's a lot of voids behind your culvert, you're going to want to use an expansive 2-part polyurethane grout. Michigan, we like to use Azo grout 551 for doing injection culverts when we suspect there's a lot of voids. Like I said earlier, you can kind of tell if there's voids behind your culvert based on the behavior of the road and the slope above. Here's an example, though, of where you wouldn't use a hydraulic cement to seal your crack. If you have active water flowing out of the walls and cracks in your culvert, like pouring out, leaking out, dripping out, however, you're going to want to use a hydrophilic grout that activates in the presence of water. This Azo grout 675 or the 443, it's actually called a water stop grout, so it'll actually react with the water and seal that joint up. Going back to these CMPs, the holes in the culvert bottom here, what can happen is during high flow events, it'll actually start sucking the water out sucking the soil out from the holes and sucking out your culvert bedding as the water goes over it. And that'll cause some undermining, destabilization of your culvert bottom. It'll even cause possibly some settlement, and that'll start pulling apart your culvert joints. In Michigan, we like to use this concrete cloth to mitigate culvert bottoms like this. The concrete cloth we use is from the Milliken Company. It's actually pretty versatile material. You can use it to stabilize drainage ditches. You can use it to stabilize failing roadway slopes. It's pretty easy to install. It's basically a hydraulic cement impregnated fabric that you can just roll out, staple it down, or anchor it down to a slope, anchor it to your culvert, and then you just wet it. That's all you got to do, and then it sets up like a concrete. Here's that culvert that had the holes in the bottom. It's got the concrete cloth all established from one end to the other, and this does, like Travis said, it does end up something like this will end up reducing the friction of the bottom and increasing velocity. Another thing we like to do is in Michigan we have a lot of our box culverts have these weep holes, and they're just not meant to be there forever. They don't work effectively, and they let in a lot of sediment from behind the weep hole. And we, as covered previously, the sediment infiltration causes problems above. This company in Michigan decided they were going to fix weep holes. They made called Jet Filter. So they made this maintainable weep hole. So you just get it sized to match your weep hole that you have on your bridge. You can stuff it in there. You can see in this picture there's a big flange. So the outer ring of bolts are anchored into the concrete of your box culvert, and then the inner ring of bolts, though, that's the actual jet filter, the weep hole maintainable drain. So you can unscrew it, you can maintain it, you can clean it out, and then screw it back in ever so often if you want. But it does filter out all of the soil, so you don't have that infiltration into your culvert anymore. So, and just there's always opportunities to innovate. This is the southwest region of Michigan DOT's bridge crew. You know, they're out for a drive one day and they see this farming conveyor belt farmer was getting rid of. And they approach the farmer and they're like, hey, can we have that since you're getting rid of it? And he's like, yeah, sure. And so they put some pontoon floats on it. And now they got this like grain elevator on pontoon floats to deposit riprap into a culvert if they want. Not to be outdone, our bridge crew that operates in the thumb is like, well, we can outdo that. And so they made their own float box pontoon boat of a riprap dispenser. I'll show you a video of that in operation. So they fill up this box with riprap. They can float it into the culvert and place it right above their scour hole. You're going to see here he's going to pull a lever and it's going to drop all of it right where he wants it.
Wow, that's really slick. One thing I would mention on those last couple slides is that if you get a hold of a hydraulic engineer, you know, they may suggest that you need much larger rock for it to be considered, you know, a engineered scour repair. But one of the things that I like to promote is this maintainable scour countermeasures, right? Like,
yeah,
you've certainly improved the condition that was there now. Yes, if you have a huge storm event, it may wash out, but it bought you some time during that storm event that you can go back in and do it again. So I've always been an advocate. Of course, I'm not a hydraulic engineer, but an advocate for, you know, do what you can. If you can't get jetty rock under the bridge, well, then maybe you get in something smaller.
Yeah. They're just out there fixing problems, you know, and I like it.
Yeah.
If you ask a hydraulic engineer in the state of Michigan, they're going to tell you that there's no riprap big enough to mitigate scour.
Yeah. Hopefully we don't have too many hydraulic engineers on the line. We appreciate you.
Yeah, I appreciate the hydraulic engineers.
Yes.
But
we have limitations sometimes on what we can place. And I've worked with some great ones where I just said, hey, look, I just can't get that rock in there.
Yeah.
Like, either we do nothing or we do nothing or we do something. No, like, do something.
Yes. So, that's what it's a lot of times it comes down to. It's either do nothing or do something. Mm-hmm. And do something, like you said, is much better. With that, I'm going to turn this slide over to Travis to talk about.
So most of what we've seen and shared today is crew removal. And I understand that there may be folks on the line here that say, that's great, but I don't have a crew, or my crew's not equipped to do this kind of maintenance. What do I do? And we have been in the process of reaching out kind of across the country to get more information on who's contracting this kind of removal. And there are some examples out there for contracted, and it's an effort that we're going to continue on with and probably have some kind of a follow-up document in the future. But from what I've discussed so far and we've learned is that, if you're contracting drift removal, it's really hard to put together a normal plan, spec, and estimate package where you've really defined the scope of repairs. So what we've heard from some contractors is they go, it's usually time and materials. Like, we'll show up, we'll bring equipment, we have an on-site meeting with the owner to say, okay, this is what we're looking to do. And then they'll go and start to remove it. Maybe it takes a day or maybe it takes a couple days. But that's kind of how it's being monitored. It's a partnership with the contractor. Not to say that there's not contracted full plan specs and estimate kind of removal that's out there, but we haven't seen a lot of it or any examples of it actually that I've been able to find yet. And then one of the comments they had was, if you require permits, you need to have the agency handle that piece of it, which is kind of a challenge for the contractor to initiate. And then consider having an on-call contract in place. Sometimes this drift removal, actually often, it can be an emergency situation. Like Jason showed some photos of those, the entire hydraulic opening being plugged with debris. That's an emergency situation. You could be looking at losing your roadway or the bridge quickly. And in those situations, you need to have someone that gets out there quickly. And I would encourage you to reach out to your contracting community. A lot of excavating equipment might work well for this. We have seen where like the heavy wreckers have been out there and also been able to assist in drift removal. And so there's some opportunities there, and it's an area that we've identified as not having quite enough guidance to the overall bridge community, and something we're gonna kind of push on a little. So with that, Jason, I think if you want to advance us to the question slide, I do have a few questions that I've been answering most of them as we go, but there's a few that are worth a longer discussion for sure. And the first one that I flagged for us to discuss is how to prevent drift in the first place. Are there things you can do in design or in maintenance so you don't have these problems?
Prevent drift?
Yeah.
I don't think that's possible.
So I did throw out some suggestions.
Modern bridge design. So if any bridge gets replaced these days, they're gonna, best practice is to put them on piles to a depth that they're not scour critical.
Right. Avoid piers in the water as much as you can, which is also going to be kind of incorporated in current bridge design anyways. And then if you do have to do it, limit the number of columns and the number of piers to the greatest extent possible.
In Michigan, we do a lot of we did bridges in the water with solid piers. So you don't have that column to get hung up on. I mean, you can still get jammed up on the nose at the front of it, but you're not going to have all the snags in between with the columns.
Yep. For timber piles, we've also seen where we've installed a bunch of kind of fenders around the piles, boarded it up kind of to turn it into a giant wall. There was at least someone out there that was installing the drift preventer that was supposed to kind of be out in front of the pier that was kind of help divert logs one way or the other. I don't know that I ever heard that worked well. I've seen where they've installed like cones, kind of like I keep using my hands for hand gestures here, and I never turned my camera back on, but you kind of got, make a point and work it around that way. Another question we had here is there a point where you would recommend the silt removal? What's the trigger that tells you it's time for me to get my remote controlled dozer out there and pull all the silt out?
I mean, I haven't really thought about that. I mean, I would think like if you've lost 25% of your hydraulic opening in a culvert, I would say it's time to get out there before it starts, because you're getting to the point where more logs are going to get snagged up. You're getting to the point where the stream might start diverting somewhere during high flow events. So, I mean, I don't know if you have a rule of thumb, Travis.
You did better than I did. My comment is basically once you start thinking it's impacting the hydraulic opening, it's time to start looking at it. But yeah, something in that 25% range probably seems reasonable.
You've also got to consider where is the stream bottom, because in Michigan we'll install new culverts and we'll have to greatly oversize them and then set the bottom of the culvert like 2 feet below the existing riverbed, so that, you know, it looks like a natural river bottom from one end of the culvert to the other for the fish.
Another comment we had here is you showed that crack injection repair and filling the void behind it. Would you be willing to throw out some kind of a service life you might suggest for that kind of a repair?
I mean, once we've done that, I haven't seen any failures. It would just be something that to make sure that the maintenance or the inspector knows that it's been done, and, you know, so they can take a close look at it to see if there's more leakage. But like I said, I haven't seen a failure.
Yeah, I haven't either. I don't know that they were ever the culverts I was like, this is the best culvert we have, but it was, you know, it was off of the to-do list for sure, and it hadn't come back on in my time.
Yeah.
Let's see. There was also a question regarding, there was a comment on, you know, do we know what the laws are for a specific state, such as California, for permitting? And my suggestion to them is, for any state, is to reach out to your DOT and ask them, what are you doing? Because I guarantee they're doing all the activities you showed here today. Yep. And they very likely have a best practice document that guides them. And I would ask them for what kind of a permitting can you do to piggyback off of what they've already done.
Yeah, and I was looking at it. It looked like some states had some kind of blanket understanding with their environmental agency that if we've got something that's jammed up against the bridge, we are permitted to go and take it out with, you know, in a very streamlined way. You know, if you follow, like you said, a best practices document. You know, we've also done in emergency, we've done drift removal in emergency, where we've just, you know, you just go out there and you do it. And then you notify the environmental agency that, hey, we're just out there. You do it afterward.
Right. I mean, right. And a lot of times this is an emergency situation. You can lose your bridge or the roadway. So there was a question here on beaver dams. That's funny. The original presentation had some additional beaver dam discussion. I think it's more common here in the Pacific Northwest than it is in Michigan. And so, but beaver dams are going to be handled very similar to the drift removal. You just have a lot smaller pieces of it. And so usually those grapples that you saw in some of those videos, they try and start getting at pieces of it. And you got to just keep working at it. Those beavers get it tied in really well. So it takes a while to be able to break that nest up. But they're definitely really good at installing those in locations. There was a question also on here on if you've got a steel, a ribbed culvert, and it's corroded out along the bottom, what are some suggestions for how to do that repair? And I'd even see that question with that. You showed that concrete blanket, and
we use that concrete blanket when we have that problem.
Okay. So I've usually looked at the concrete blanket as being a good opportunity to stop it from getting worse, but I didn't really usually consider that it restored the structure of the pipe.
No, I wouldn't consider that restoring the structure of the pipe. I didn't include it because it's its own presentation, but in Michigan we'll use a geopolymer spray liner that's designed. The design of that geopolymer spray liner is assuming 100% section loss of your pipe. So if that pipe is 100% gone, that geopolymer spray liner will act on its own. I mean, obviously that reduces the hydraulic opening.
Right.
Depending on the size. Let me see, I did a 14-foot culvert underneath a US highway in Michigan, and that was 3 inches deep. So all the way around, so you lose 6 inches of your hydraulic opening. So that does restore the capacity. So,
and I've also done where we've installed some shear studs above where it's rusted out, and then installed some reinforcement along the bottom, and then cast it or poured in that invert. I'll say that the environmental permitting has made that much more difficult to achieve in recent years. It's considered too long of a fix without improving fish passage. So if whatever you do ends up meeting fish passage, they were okay, but otherwise they're like, build a bridge. Okay, we are at time, and there's a ton of great questions still in here. Jason and I will go through the questions and get responses back to those, and we'll include those as part of the wrap up and what we send out after the fact. Jason, thank you for a fantastic presentation. I thought this was very informative. Yeah, and what else? Any parting comments, Jason?
Just make sure you drop in the chat or the questions box suggestions for future presentation topics.
Yep, absolutely. And I would also encourage folks to consider attendance at one of these bridge preservation conferences, especially if they're somewhere within striking reach for you. Often the conferences are highly motivated to get local bridge owners in attendance, so maybe even scholarship opportunities if the registration fee is challenging for you. You can reach out to myself or Jason for more information on some of that. No sales pitch. This is all nonprofit stuff, but it's great to have this room full of people that are all trying to preserve bridges and bring a laundry list of your questions and get answers for free.
And what I love about it, these bridge conferences, is the in-person ones, is the vendors are there, the consultants are there, the DOTs are there, and they're all getting together, not trying to sell each other things. They're like, hey, we've got this problem, you know, what can we do? And I've had vendors like invent new things to fix problems in Michigan, where I've gone to them and I've said, I've got this problem and I need some help. And they're like, we'll invent that for you.
Yep. I frequently have had other people do my work for me at these conferences. So very useful for that. Okay. Well, thank you, everyone. Go ahead, Stuart.
Travis Holland just said there were some questions about the Denver conference. The agenda is being finalized at this time. If you'll check that website that I sent a link to in the next week or so, you should have the final agenda and presenters that will be presentations that will be there. There will also be a technical tour at the Denver conference on non-destructive testing. It'll be a hands-on demonstration off-site the afternoon of Tuesday afternoon. So like I say, a lot of good things going on there. Thank you.
Yep. Thank you all. Have a good one.
Thanks.
Yeah.